Good morning, good evening, wherever you are, and welcome to episode 88 of the Cloudcast. We're back and coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And, you know, we haven't talked about networking in a long, long time for no good reason. But, you know, the networking world, software-defined networking, whatever the heck that means, seems to be sort of blowing up these days. And so we decided we're going to get an expert on this. We're going to get our good friend Ivan Pepelnjak back. Ivan, welcome back to the show, man.
Well, thanks for inviting me. I'm glad to be there.
It's been a while. So, you know, before we jump into any networking stuff, you're always really, really busy. Lots of stuff going on. What are you doing these days?
Oh, it's all overlay virtual networks. It looks like wherever I go, I talk about them. Okay. It's crazy.
And you're still you're still writing for iOS Hints, the blog.
Yeah.
I'm
still blogging. I'm still doing webinars. I'm occasionally used by my company.
So for anybody who's never seen Ivan's webinars, you do them on like a subscription basis, right? Or some of them are per like one-off, and then sometimes they're subscriptions?
Well, you know, it all started as one-offs, and it all started as live sessions, and then someone said, well, could I just buy a recording? And I said, well, that's a good idea. Let's do that. And then someone said, well, how could I get access to all of them? And that's how subscription was born. So now you have all three options.
Okay, cool. So yeah, so if you're into networking, definitely go take a look. We'll put all the links to the addresses in the show notes. You also do some stuff occasionally, not as much anymore, but occasionally you're still with Greg and Ethan and those guys on Packet Pushers as well.
Yeah, occasionally they invite me.
Yeah, so they're cranking along. So you know, we've always been very much in awe of what the guys at Packet Pushers done. They're really good about kind of what's real, very networking centric. They don't get off on a whole lot of topics. You know, it's a huge mix of what's going on in technology. The vendors come on, they have customers come on. So those guys are great. So if you're not listening to Packet Pushers, and again, if you're into networking, go listen to those guys.
Yeah, you definitely should.
So let's talk a little bit about what's going on in networking. You know, for last time we had you on, it had been a really long time that, you know, we sort of said, you know, networking hadn't changed tons, which is kind of not totally true. I mean, it's always evolving. But, you know, it feels like the last 6-8 months, it's gotten, I don't know if it's been so much change or if it's driven by, you know, kind of marketing and positioning. But, man, it feels like there's just a lot of confusion between SDN and now you know, network overlays, network virtualization, network functions virtualized. Like, what's really going on these days?
Oh, not much.
Okay.
You know, it's like teenager sex.
Everybody talks about it, but nobody's really doing it.
Yeah.
Okay.
So there are some things going on in the SDN space, and we've been talking about that, I think, in the other podcast. 90% of SDN you see out there is SDN washing.
Okay.
So people take whatever they have and they maybe add an API to a device, or they add an API to the network management system, and they call that SDN because, wow, now you can program that thing.
Yep.
And, of course, you could do that before, but it wouldn't be a REST API, so you would have to learn some more arcane protocols like maybe SSH or Telnet. And now it's so much simpler because now it's in JSON formatted and over HTTPS, so big deal.
Yeah. And so, but it was interesting for a while. All the SDN conversation was sort of OpenFlow. That was, you know, it was this. We're going to separate the control plane from the data plane, and we're going to use OpenFlow as the controlling protocol. And then it felt like sort of two things happened. You know, at least from my viewpoint, sort of two things happened. One, Cisco obviously came along and sort of said like, whoa. Number one, we can't just have one protocol because Cisco's never had just one protocol. And then the other thing that was kind of weird, and maybe I got this wrong, the Nicira guys kind of came along and said, we got all that OpenFlow stuff wrong. now we're doing it differently. Like, what happened in there? I mean, I guess more importantly, like, what did the Nicira guys really say? It feels like, I mean, what went on there?
Well, let's say that a few people got a dose of reality.
Okay.
Now, the things that I've always been talking about, if you want to program actual hardware, that's hard.
Yes.
And actual hardware is very streamlined, and it has pipelines that do specific things very fast. And if you want to misuse that hardware in a totally different way and program it through OpenFlow using, let's say, totally different mental picture of what the hardware could be doing, then of course you will not get far. And the Nicira guys realized that, and they said, well, forget hardware. We'll focus on the edge, and our edge is the hypervisors, where we can do everything in software. So we can do everything we wish in that software. And we'll just use the hardware in the middle as a transport mechanism.
Okay. So in essence, you could almost make the analogy, and this might be really bad, but if you think about just a traditional computer, you've got I/O, which sits at the edge, deals with whether it's Ethernet or it was dealing with printers and parallel ports. There's a bunch of guts in the middle that was a bunch of silicon linking CPUs and memory, but nobody really did anything with that stuff. And then you had an output like a monitor. In essence, VMware wants to live completely at the edge and makes the middle look like just one giant. I don't want to say one giant flat network, but I think what they're saying is like you can leave the core network, the hardware that's in the middle alone. You can make it faster if you want, but we really don't care about it. As long as it passes IP packets, we really don't care.
Exactly.
About it. Okay.
So the analogy I like to use is Skype.
Okay.
As you know, like 20 years ago, we would be talking on a regular phone. And there would be a circuit going end-to-end from your phone to my phone. And there would be like probably 30 different voice exchanges involved in that call.
Right.
And every voice exchange would keep state of our voice circuit. And of course, that was slow and expensive.
Right.
And today we're using Skype, so all we need is internet between us, and we don't really care. And no one in the middle cares about our voice call.
Right. Right.
So you see, we did that for voice, first with voice over IP and then with Skype, and we did that with storage a long time ago. First with NFS, then with CIFS, then with iSCSI, then with NFS version 3 or whatever they have now, and now it's time to do the same thing for networking.
Okay. So in essence, I mean, in essence, what they're doing now is sort of an overlay, and people, sometimes talk about it as if it's brand new. I mean, we've done overlay networks, whether they were GRE tunnels or MPLS or IPsec for a long. I mean, is there anything? And they all had their pros and cons, right? I mean, the pros of it were you could sort of manipulate the network to go wherever you wanted to. You could kind of pseudo avoid hops and things, but it also had the challenge of, encapsulation sizes. You lose visibility to certain things. I mean, are the same sort of pros and cons still here?
Of course.
Okay.
There's nothing new under the sun.
Okay.
And you more or less mentioned them all. The only difference today is that most of these things happen automagically. Mm-hmm. So when you need GRE tunnels between hypervisors, they just happen. You don't have to provision them. In the good old days, we had to provision GRE tunnels on the routers, for example.
Okay.
And the other thing is that this particular application has very limited scope. So it's not like we would be running GRE tunnels all over the planet. We're running them, let's say, within one availability zone in a data center. So we know how the underlying infrastructure should look like. So it's not like we would try to reroute the tunnels around or do whatever fancy with them.
Yep. Okay. Now, gosh, it's been more than a year. It's probably been almost 2 years, give or take. There was a lot of buzz about VXLAN and NVGRE, sort of the first set of how do we get around the vMotion challenge. It was kind of an alternative to network-based OTV, extending layer 2s, and then there was sort of some buzz, and then it kind of went away, and some of the hardware vendors, like Arista, for example, kind of said, hey, we do VXLAN termination, and then you can come off in VLAN. But it doesn't feel like people are talking about those as much anymore. I mean, I know Cisco made some announcements where they said, well, we do VXLAN without multicast, and so it should be simpler. But is VXLAN or NVGRE or any of those overlays that aren't kind of controller-based, are those still viable? Are people still talking about those, or did they just kind of become less noise and they're kind of in reality?
Okay, so is anyone talking about HTTP or TCP today?
No.
You see.
Okay, it's just become part of what we do.
Yeah, well, these are different ways of putting Ethernet frames on the wire. Which bit goes where? How long the header is? That's boring stuff. Who cares about that?
Okay.
So now you even have the products that use, for example, VXLAN internally between hypervisors, because it has some interesting properties, and they use MPLS over GRE when talking to the external devices, which supports that encapsulation. So people have even started to mix the different encapsulations inside a single product. Because it really doesn't matter what the encapsulation is.
Okay, so it's become just like the typical protocol soup that we see in every network where you've got...
Absolutely.
Okay.
So the really important part today is how do you figure out where the VMs are?
Okay.
So you have some VMs sitting at some hypervisors, and this source hypervisor has to know the IP addresses of the other hypervisors. So how do you figure that out? And Cisco sort of cheated by saying, well, we will not exactly use flooding, we'll use IP multicast, which is better than flooding. Mm-hmm. And then everyone else came along saying, well, you can do that if you wish, but we really have control plane, because if we have visibility into vCenter or OpenStack or whatever it is, why should we use flooding? Why should the switches learn where everyone is if we know where everyone is? Okay. And this is what Nicira is doing. This is what Microsoft is doing with the new System Center. And this is what Cisco will be doing once they actually release what they've been showing since January.
Okay. So nobody's built. I mean, it used to be back in the day, you had to create these sort of discovery protocols where endpoints would multicast, flood, whatever they did, they'd sort of tell the world, hey, here's where I am. Went all the way back to the Novell days when services would announce what they were doing. Mm-hmm. Nowadays, you've the control point, like you said, vCenter, OpenStack, System Center. It knows where the hypervisors are, and to a certain extent, it should know where the VMs are. And then people are just querying those things via API to figure out where they are. They can then go down to the switches, figure out where a MAC is, and kind of correlate where things are in the network.
Perfect summary.
Okay, gotcha. So that's kind of the state of what's going on with the buzzwords and so forth. You go out, you talk to a bunch of people that are doing this. You're helping to do designs. I mean, what are you typically doing in your designs in terms of overlays or helping people do availability? Like what's been changing in the designs that you've been dealing with, let's say over the last year or so, in terms of either what you deploy or what people want to do?
Not much.
Oh, okay.
So some reality check here. If you want something that runs today, mm-hmm. and if you're not a huge cloud provider, then you would still use VLANs. So if we're talking about, let's say, a private cloud in a reasonably sized data center, a few tens of physical servers, which would translate into, let's say, 50-to-1 virtualization ratio, that would be a few thousand VMs, mm-hmm. You would still use VLANs.
Okay.
Because you could terminate those servers on 2 or maybe 4 switches, so why complicate your life?
Right.
The only thing I'm telling people is stop using physical appliances.
Okay.
Stop using physical firewalls, stop using physical load balancers, because if you virtualize those and if you glue them together with the whole application stack and package all that, then you can take all that and you move it to a different data center in disaster recovery scenario, or you move it to the cloud if you wish. You move it anywhere you wish.
Okay.
You're totally portable.
Yeah, that makes sense. That makes sense. And you can then start using a bunch of the fairly mature automation tools to help you do that, whether it's Site Recovery Manager or Chef or Puppet or now
whatever have you.
Whatever you're familiar with. Now, talk a little bit about this, because you live. I mean, you're talking to a lot of the guys that are doing networking, have been doing networking for a long time. What's your sense of, there's all this talk about, well, you can now script things, you now have APIs, people should be learning Python or whatever language. Like, how quickly is that happening? I mean, like, how, in the past, people wrote scripts, but they were Bash scripts, or maybe they were Python. There wasn't a whole lot of network programmers. All of a sudden, people have this I almost want to say, like, it's a misguided notion that all of a sudden these network guys are going to become programmers. I mean, it's really kind of advanced scripting, isn't it? Or what is the state of people dealing with non-CLI stuff?
So the first thing you have to ask is, where do you want to go? Because if you go down the overlay networking route, then all you need from your switches is simple IP routing. So there's nothing to program there.
Right.
You deploy the switches, you connect the servers to the switches, you configure an IP subnet and OSPF on the switch, and you do it once. And then hopefully you don't touch that switch until it dies.
Okay.
That's how overlay networking simplifies the data center switching, for example, and this is why the networking vendors hate it.
Right. It's like a Skype example again,
Yeah. Or, of course, if you want to deal with VLANs, then there's all sorts of things you can program on the switches, and the networking vendors love you.
Yep.
So you could program VLANs on the edge ports. You can program access control lists on particular VLANs and so on. So there's lots of stuff to play with. And if you want to go down that route, then yes, absolutely, you should start learning some programming skills.
Gotcha.
But there, you have to be careful, because if you are on your own writing some scripts and they even work, do you really want to use them in the middle of the night when you're away on vacation?
Right. Yeah, you start getting into, if you get hit by a bus, there's a lot of people who are in trouble, right?
Exactly. So there's a very long path between where we are right now, everyone talking about programming, and the stage where, let's say, network programming becomes a serious production-ready thing like application programming.
Right.
We just don't have the processes, procedures, things like that.
Yeah.
Well, we don't know them.
Yeah, and in reality, I think, networks change in that you're adding capacity from time to time. We're sort of past the days when it was like, bringing in VPNs was a big deal, or remote office. I mean, we're basically wired everywhere for everything. It feels like the major events where you'd have a big change is, yes, you add capacity, you have a disaster where you lose a big chunk of something and you've got to move it. But networking in general isn't as dynamic in terms of change and so forth as like servers, where it's like, hey, I may spin up 2 or 3 new projects, which from a server perspective or a storage perspective is a whole lot of change, a whole lot of things. Is that still pretty true? I mean, the network changes. It has some dynamicness, with the protocols, but it's not this heavily changing thing like servers and storage tend to be.
Well, also, I would disagree about storage being dynamic.
No, it's not. Yeah.
I mean, if you take a look at what's going on, you configure this huge LAN, and then you run VMware file system on it, and all that happens is there are new files created.
Yeah, that's true.
That's not storage.
Yeah, that's just capacity. Yeah. You're just throwing stuff in the closet, right?
Yeah, exactly. I mean, you pre-configure the closet and then you throw stuff in until it's full. And the same with network. You pre-configure the plumbing and you hope you never see the plumbing again.
Okay.
If you do, you have a problem.
Right. Well, and you deal with it like you deal with your closet. You open the door and then you sift through it, and you wish you had an extra closet in the house, right?
Exactly.
Right. Now, talk about now. There's a couple of other kind of things that get talked about a lot in networking these days, but I'm not sure how viable they are. So one of them is around the OpenStack world. So my audience, I think, is pretty well versed in OpenStack. people talk about quantum as if it does some magical thing, but quantum really is just, create VLANs, assign IP addresses. Yes, it could talk to, say, Nicira's controller. It's got an AP, but quantum isn't doing anything that traditional networking doesn't already do today, correct? It's just a programmatic way to define it?
Yeah, quantum is, let's say, an abstraction layer.
Okay.
It's an abstraction layer that allows you to create virtual segments, virtual subnets. Let's call them virtual subnets.
Yep.
And of course, someone will tell me I'm using totally wrong terminology, and I don't care. And then you assign IP addresses from those virtual subnets to individual VMs, and you have a router node which links together those virtual subnets. And I think now they have load balancer as a service,
right,
which has one outside IP address and distributes that between the VMs on the inside. Now, how you implement that is a totally different story, and that's where the quantum plugin comes in. So you could implement this as VLANs. And if you want to implement this as VLANs, then you can use either the traditional Linux Bridge plugin, which is supplied with Quantum Distro, or you can use the OpenVSwitch plugin, where OpenVSwitch is just the replacement for the standard Linux Bridge. Mm-hmm. Yet again, comes with the distro, and it's also VLAN based. And then you can have all sorts of different plugins from different vendors. So, for example, Cisco has a plugin, and what they do is they actually create physical NICs out of the Palo chipset on their NIC. Mm-hmm. I don't think it's exactly single root I/O virtualization, but close. And then the VM VIFs would be mapped into those physical NICs. So one NIC goes to one VM. Okay?
Yep.
And so a VM would be sort of connected straight to the first top-of-rack switch.
Okay.
I think Cisco calls this VMFX.
Oh, okay. Okay, yeah. And for anybody who's not familiar, Palo is the sort of technology Cisco uses on their NIC cards within the UCS. Yeah. It allows them to map a VM to a virtual port.
Well, Palo allows you to clone the same physical hardware, the same Ethernet NIC, into like 50 Ethernet NICs that all look like physical Ethernet NICs.
Right. Okay, got it. Okay.
So that's Cisco's idea. And yet again, their plugin implements the virtual networking with VMFX and top-of-rack switches doing VLANs, and it looks to Quantum like you can create virtual segments. You don't care how they got instantiated.
Gotcha.
And then NEC has their OpenFlow controller, and their OpenFlow controller works with OpenVSwitch, but it programs that through OpenFlow. And when they talk to Quantum, they collect the data from Quantum saying, I need this virtual subnet here and this IP address there on the VMs and so on. And they program the OpenVSwitches through OpenFlow like they would in their traditional virtual tenant networking solution.
Yeah, okay.
So Quantum is just an abstraction layer.
Okay. So, yeah, and like you said, there's beyond the abstraction, people are doing slightly different things, whether they're...
Yeah, you can use any technology you wish underneath the Quantum abstraction layer as the Quantum plugin.
Okay. And it sounds like the plugin framework is sort of similar to what vCenter did years ago, where it was like plugin framework for storage, plugin framework for backup, plugin framework for other. It allowed multiple vendors to basically have a similar sort of look into the system, but what they ended up doing under the covers was completely up to them.
Yeah. So let's put it this way. From vCenter perspective, Quantum plugin allows you to create port groups.
Okay. And
connect VMs to port groups. How those port groups work, that's the job of the Quantum plugin.
Gotcha. Okay. Yep, absolutely. So that makes sense. Now, let's kind of hit on one other thing, and this is something I'm trying to wrap my head around. So there kind of feels like there's a divide between the super large data centers, the Google size ones, and Facebook or Twitter, which is in essence, they're giant factories. They're just giant bit factories. People tend to want to reference them. Most people have no idea what really goes on inside of those things because they've never seen inside of them. They've only read about them. But you hear about these, super giant companies who are like, I'm building my own switches, I'm building my own software, I'm doing my own thing. And then people want to kind of correlate that to what's happening in the rest of the market. And they're going, well, you're going to want to build like Facebook. You're going to want to build like Google. You're going to want to use commodity this. Like, how much you deal a lot with, either medium-sized service providers, enterprises, sort of everything outside of that. Do you see anybody in the world that you deal with that's dealing with sort of these, what you'd consider commodity hardware, or people writing their own networking stacks to run on this, or is that really a super niche for those web guys?
It's super niche.
Okay.
So, for example, Google made a big show sometime last year how they deployed OpenFlow in their network. Mm-hmm. And when you go and actually start looking into what they did, they decided to become a router manufacturer.
Right.
They wrote their own router operating system.
Yep.
Will they open source it? I doubt. It's their competitive advantage.
Yep.
But, they sort of decided we want to be like, let's say, Arista, one of the smaller companies. Mm-hmm. And so they had to invest approximately as much money.
Right.
Does it make sense? Well, it makes sense to them. Does it make sense to me? No, it doesn't.
Right. Yeah, and that's the, it's one of those things within our industry that's become sort of weird, is everybody goes, well, you should operate like those guys. And for one, I don't think most people understand how those guys operate. And number two, like you said, they make so much money, and in essence, it runs their business, right? It's their competitive differentiator. Most people can't emulate that. They can't afford as many engineers. They can't afford the quality of engineers. And for most people, it wouldn't give them any sort of advantage any more so than they could get out of an Arista or a Cisco or a Big Switch or somebody else. Okay, so that's
Plus, you have to ask yourself, what's your core business?
Yeah, if you make tractors, networking isn't your business. If you're in pharmaceuticals, networking is not your business, right?
Yeah.
Google running a massive, highly available network, that is pretty core to
their business.
Yep, yeah. Absolutely.
And the other analogy, if you're building a Ford Focus or whatever is popular these days, you don't look at the guy building a space shuttle.
Yeah, exactly. Yeah, different characteristics.
Doesn't work.
Exactly. What's so this has been good. There's times when I think people like a sense of reality because there is a lot of buzz. I guess sort of last thing. What's your take on what's going on around this Open Daylight sort of consortium thing? It felt like it had some pandering and marketing to it, but then Big Switch did some stuff that kind of made people think about it. I mean, what's your take on the controller market in general? I mean, there's some people that are doing commercial stuff. There tends to be this open source thing. Where do you think the sort of controller based world goes in the next couple of years?
No idea.
Okay.
Honestly, I mean, when the rumors about Open Daylight started coming out, I wrote a blog post saying, well, is this the Internet Explorer or is this the Linux of the controllers? Mm-hmm. So in both cases, is the free software to kill the commercial competitors.
Yep. Yeah.
So Big Switch has a big problem.
Yeah. It tends to look that way. I mean, you never know where people will end up. But I mean, you have to imagine they're looking for a big payday like Nicira was. And now they have the challenge of, basically, how are you going to monetize what they did? Have you, from a technology perspective, have you had any chance to work with one set of controllers versus another one? I mean, are you seeing what level of maturity are those things at, whether it's a Nicira or a Big Switch or Cisco's or any of the other ones?
Haven't seen anything from Cisco running. Mm-hmm. NEC, their programmable flow controller, it's been around for a while. It's running in live networks, so that one is production grade.
Okay.
Nicira, I think, is also production grade. They claim they have pretty large deployments. They published some scalability figures a few days ago where it looks like they're actually running a 5-node controller cluster controlling something like 12,000 hosts.
Oh, okay.
So that's impressive.
Yeah.
Haven't heard anything about real-life deployments of anyone else.
Okay. And that sounds about right. Those seem to be the ones that keep making progress. But yeah, I think for a lot of people, it's how real is it? I've seen some people lately who have been kicking the tires with Cisco One, or been kicking the tires with sort of the floodlight code and stuff. But it feels like it is very much just kind of kicking the tires beyond the couple that you laid out. So good, yeah. Good. Well, listen. This has been as always a great conversation. I tried to keep it sort of open ended, and we could just kind of see where things would go. So thank you very much for the time. Where you're over in Europe. Where are you going to be around? Where can people bump into you above and beyond what goes on iOS hints and all the things that you're due from a publishing perspective?
Oh, virtually always on Twitter. If anyone sends a tweet to @iOS hints, I always respond. In real life, I'll be in Silicon Valley, hopefully, beginning of September. Then I have a few conferences around Europe. And by the way, it's all on my website.
Okay.
So ipspace.net/presentations. And there they can find all the conferences and everything I will be attending in the next almost a year.
Okay, fantastic. Well, listen, Ivan, thanks again for always jumping on. Hopefully we can get you back on more frequently. I know everybody...
Well, absolutely.
So, very good. For everybody who's out there, if you like the show, please tell a friend. We continue to grow. We're having a lot of fun with it. If you get a chance to listen to the mobile show that we're doing called the Mobilecast, Brian Katz is doing an excellent job on that one. As always,
that's a fantastic one.
Good. I'm glad you like it. We're trying to kind of broaden out. We've been wanting to do a European one for a long time, and we may have to find some folks because I think we want to get a non-U.S. centric view of things at some point. So, folks, if you like it, tell a friend. You can find everything about the show on the Cloudcast net. Thanks again to Ivan. Aaron will be back next week, and everybody have a great weekend.